question 4. So pretty similar, I think, to a question a bit earlier on, just the other way around, I think, really. So first things first, we're told that this is the acceleration. We're being asked to find the values of t for when this equals 0. So this equaling 0, well, let's just factorise t minus 3 times t minus 6. So our two values of t for which the acceleration is 0 are 3 and 6. Now for part 2, we're told that when t is 3 the velocity is this, and we're being asked to find the velocity when t equals this. So finding velocity, so we need an equation for finding velocity. Well, velocity is the integral of acceleration with respect to t. So we are going to go and integrate this. So if we integrate each of these three terms, we get this plus our unknown c. Now they tell us when t is 3, p is 9. That allows us to work out that c is minus 27 over 2, minus 13.5. So our revised formula for our equation for v is this. Now we're being asked to work out what v is when t is 0, so obviously the first three bits drop off with t being 0, so we're left with the velocity of the constant that we've just worked out, minus 13.5. Now for part 3, show that the direction of motion of p changes before t equals 1. Now remember, when the direction of motion changes when v equals 0. So let's just go and see what happens when t equals 1. So substituting t into our velocity equation, so the one we've just worked out, we see that when t equals 1, v is in fact plus a third. So we can see that the velocity has gone from being a negative at t equals 0, minus 13.5, to a positive when t equals 1, a positive being a third. So it stands to reason then that somewhere between 0 seconds and 1 second we have gone through v being 0, so we can conclude that there's been a change of sign, so the direction of motion has changed.